I'm Joel Sanders, and I'm today's host, and I'm really excited to get to sit with two legends, two pillars of the industry, Dennis Keiser from Keiser and Mark Verstegen, founder of EXOS.
Makes it sound kind of old. Wise, maybe.
Seasoned.
Seasoned.
That's
okay,
right.
I'll take that.
Well, let's chat. This is a fireside chat. So, Dennis, could you start us out and maybe take us back to mid to late 70s and tell us, how did Keiser start and why?
The history prior to Keiser was that I was hired to design Universal Gym Equipment's first variable resistance machines. And I worked there for a year. I was a consultant. And at the end of the year, I knew that this whole concept of variable resistance was a really good concept, but it was using the wrong resistance. Now, variable resistance, and Nautilus had made variable resistance popular when they came out with their first machines in 1970. And everyone thought Nautilus had invented it. It was actually invented in 1898 by Max Hertz in Austria, Hungary. So it was used against iron at that time, or along with iron, and it failed then. It was used with Nautilus, and for the most part, it failed again. And for the right reasons. Variable resistance, once you start focusing on variable resistance, it becomes a very exact science, where when you're lifting a rock or you're lifting iron, yeah, it might say 50 kilos on the side of the bar or something, but it's really never 50 kilos unless it's sitting on the bar or moving at a constant velocity. And in the range of motion that a human being has, it's never at a constant velocity. So it's either lighter than 50 kilos or heavier than 50 kilos. It's heavier when you're accelerating it, lighter when you're slowing down. So no one really cared. But once you start saying, I'm going to match the human's ability to perform an exercise, to produce a force, that now becomes more scientific. And so you have to put a very pure resistance behind that, so that you're not having to accelerate this mass in the process of doing this variable resistance cam. And that's what was happening with Max Hertz when he designed his first variable resistance equipment in 1898. And the same thing happened with Nautilus and Universal and everybody else. And so very few people have any kind of a cam on a weight stack machine anymore because it's just not worth it. But the variable resistance concept is extremely good. And so the pneumatics came about because with the pneumatic resistance, we could create very high forces with very little moving mass. So we're compressing the air, and that air acting against a piston is creating the force. But that there isn't a lot of mass that has to be accelerated and decelerated. So it becomes very easy to build a force curve into an exercise machine and have that force curve remain consistent regardless of the training speed. See, Nautilus and Universal had to pick a speed in which they wanted their machines accurate at, because if they changed the speed, that changed the forces required to start and stop the weight stack. So they had to, Nautilus decided to, they designed their machines out on 2 seconds and back on 4 seconds. Universal, when they asked me to design their first machine, I had to ask them, what speed do you want it accurate at? Because I can only make it accurate at one speed. They said, well, we would like to make it accurate out on 1 second and back on 1 second. I said, all right. So now you have these two rival companies now trying to convince the world that you got to train out on 2 seconds, back on 4 seconds to sell Nautilus, or you got to train out on 1 second, back on 1 second if you're going to train on Universal. So they each had to justify the training speed to justify their machines. I didn't want a speed limit, basically. So the pneumatics did everything we wanted because it created that very pure force with very little moving mass, basically negligible. But we could also adjust it in 1 pound increments, which nobody was able to do with the iron at that time.
Game changing.
Yeah. So, okay, so if you could break that down, because you're mentioning air pneumatics or dynamic variable resistance, speed, gravity. If I was a 3rd grader and you need to give me that physics lesson as a 3rd grader, why compressed air, pneumatics, and dynamic variable resistance versus weight stacks, mass, plates?
That's a good question. Because I've been through all the websites looking for cartoonish type education on Newton's second law. And Newton's second law says that if I'm going to move a mass, I have to apply a certain force to accelerate that mass. And it's the acceleration of that mass that takes that extra force. There is no simple definition. There's no simple cartoon that I can find yet that will actually teach a 3rd grader exactly that. But what happens is, and we all experience it, but because we live on a planet that has gravity, and we live and we have a body that has mass, we deal with this mass all the time and accelerating this mass of our body. And we kind of take it as just a natural occurrence because that's what it is. But if we stood on the top of this chair and we jumped down onto the ground, we would hit the ground and we would have to slow that mass down. Okay? And it would take a certain amount of force to do that. And then I would ask you, okay, now you go up to the top of the roof and you jump off the roof and you tell me if you have a greater force at the bottom to stop that mass or not. And you will say, I'm not going to do that because I already know that that's going to be very dangerous. Okay, I might not even survive it because you're going to hit the ground so hard and the ground is going to try to stop you, that mass of your body. You're still the same mass that you jumped off of here with, but that mass has accelerated and now you're trying to slow it down when you hit the ground. And it takes too much force to do that. It's the same thing that happens with a barbell. If I push a barbell out, I have to put extra force to get it moving, only to get it moving. Once it's at a constant velocity, then it's just the weight of the barbell. But to accelerate it, I have to put extra force in it. So I have to get it accelerated. Now I'm moving at a constant velocity. And then at the end of that, I have to slow it down. That's negative acceleration. Now it's taking the weight away from me. All right, so I'm dealing with that all the way through that movement. The problem is the human body creates its least force here. The muscle is capable of high forces here, but it's in a terrible leverage position. So it can actually, the muscle can contract a lot, but it can't create a lot of force, okay, because of leverage. But the iron is creating a tremendous amount of force here because I'm trying to get it going. Because I've got to get enough velocity because I got a sticky point. We all have a sticky point.
Sticking point here.
It's kind of in here. So I got to get it moving so I can get through that sticky point. And then once I've got it moving, now I'm out here where I'm nice and strong. but I'm slowing that weight down. And so in slowing the weight down, it's getting lighter. Then if we want to take it to a whole nother conversation later, what I'm teaching the brain to do is slow down my movements out here. Where out here, I want to be quick if I'm playing a sport. And yet I'm teaching myself, I'm training my brain to slow down out here.
Which we do not like, as you well know, at any age, at any level of performance.
No slowing down.
No slowing down. Dennis, what's the machine where you have pneumatic one side and mass on the other, leg extension machine?
Oh, we call it the Warrior. One of our guys named it the Road Warrior.
And the reason that that's a great one is you just have to feel it. And if you sit down on a traditional leg extension and you were to have someone go on the mass side and do a leg extension up and down, normal rate of tempo, what you would see is you would see a force velocity curve, but you'd see actually inside the muscle that the muscle's on and off again to manage the speed. So as Dennis said, you don't want it flying off the weight stack flying off the top. And now if you ask someone to say, now I want you to do it fast, kick that mass stack, you would see the recruitment go really high, and then there's going to be a pause as the weight stack flies up and the pad flies off, and then boom, you have to catch it again. Dangerous, as we all know. If you go on the flip side and use the pneumatic and you extend your leg, that recruitment pattern of your muscles making that thing work is like broadband. It's like fiber optic. It's so clean and efficient because it's able to do that thing regardless, as Dennis said, of speed. And that's you start to feel that smoothness. And now if I want to go explosive, it looks to us the same, but the recruitment patterns will be equally as clean. I just might have had more intra and intermuscular coordination. But bottom line, like that's just the night and day difference between trying to use pneumatics as a tool versus like mass. No problem with mass in the right situation, but we need the right tool for the right solution.
Exactly.
Do you remember, because you're right, you almost have to feel it.
For sure.
I can't even describe it to you well.
Yeah.
Do you remember some of the first time using Keiser-based equipment?
I do, and I don't even know if Dennis remembers this, but I was actually an intern part-time coach at Washington State in the early 90s, and the job that I was doing was also helping to raise funds for varsity athletics, and we raised enough funds to get new equipment, and we got a bunch of Keiser. And I was a much better athlete at that point in time in my life. I loved to train explosively, but that usually meant like throwing balls, people, other things, Olympic lifting, and obviously loved to move and squat mass, as you can tell from my legs and ass. But when I first got on that and I was doing things like, yeah, that feels really nice. He goes, now move it at speed. And my ears perked up. And I started to try to, and I could see like this wattage, like things move. It was like a fine race car, like Carroll Shelby and getting behind the GT40, like it wanted, like you could drive it more. And it was a fascinating thing in my head. And what I respected most, and I think as Keiser stands for in a brand, is not just about the great engineering solutions, not just about the equipment, but Dennis as a mentor and getting the industry to move faster, safely, but also how he's mentored so many of us. That was the first time. The second time I met Dennis was when we were at a trade show, and I'm not sure which continent it was, with Daryl Eto, and I went over, and I was still young, I was pretty eager.
I think we were here. We were in Phoenix.
Well, it might have been in Phoenix.
Yeah.
And so I was eager, and I'm like, hey, listen, we're trying to solve for this. I don't have the right tools. You would laugh with what we're trying to do to teach world-class athletes to help that best get better. Would you mind coming down to the facility? So at first I'm at his booth, and then I don't know, not long after, he's in our new facility on the grounds of Arizona State.
And this is in the late 90s?
Late 90s.
Okay.
When we had just started that off, early 2000s.
Okay.
And we sat down and started looking at what you know today as the functional trainer with the arms. And we also sat down with a rack that you could do mass work on to squat and to bench. But we then changed the pull-up handles, and then Dennis started adding pneumatics to the rails so we didn't have to use archaic bands and that weren't precise. And we needed to lift some sometimes unload the athletes so that we might do rehab in different components. And I still remember to this day that Dennis was in our conference room with his lawyers going through his patents of how he was drawing and architecting things up, and that they were capturing it. So it was almost this live time element. It was like meeting my soulmate who had way more intelligence and wanting to solve what we were all trying to solve for in the field. And that was like early, like 2001, 2002. So yeah, we go back.
We do go back.
We go back.
Yeah. It's been a great relationship.
It has been.
Relationship.
And I'll tell you, I think that goes to the power of the relationship, but the partnership, because there's nobody more intense and focused on trying to solve something properly. And sometimes he'd look at me and said, well, if pneumatics aren't the right way, then we don't need to use pneumatics. And I was like, great. Well, here's what we're trying to solve. And where you start to see the suite of where Keiser is today was us sitting in rooms with great people like yourself and the rest of our team, physical therapists and people that loves the speed part of things and the strength and power, like, the whole thing. We're sitting down and ideating, and then we're putting world-class athletes on it, and we're learning and prototyping, and that's where it all started. Those are some of my happiest times. Those are good times.
Mine too.
Yeah.
So I've heard you say that Keiser was part of EXOS's competitive edge.
Absolutely.
So, one, what do you mean by that? And two, take me through how, like you just talked about that design process.
Yes.
And masterminding and brainstorming together. What has it allowed us to do from methodology, facilities?
That's about 6 questions.
Okay,
Right there.
start with competitive edge.
Well, number one is, Dennis and I've had great opportunities to go be asked to speak in various populations, right? From world-class sport to youth sport to aging to everything in between, right? All of our fitness and health and performance. And at the end of the day, like when we would go through the EXOS methodology about what we do unbelievably well in a holistic system, world-class game plans, try to teach everybody with an N of 1, and then we need to make sure that we do the right things around their mobility and around their essentially positions, pattern, and power based on what we need to do. Sometimes we have to decrease pain to then prevent pain and ultimately help them perform so they don't go back to those other elements again, regardless of the population. So when you start to look at that, almost every presentation that we would do, it would be like, and at the end of the day, if you don't believe in Keiser, that's fine. It'll just continue to be our competitive advantage. Like if you don't get it, like we're totally good at that because our clients continue to come to us to do that thing. It's like, but I want you to get it because that's EXOS's DNA is, we're a growth mindset. We love to share. We love to solve together. That includes with our industry, which was not like that at the time. So, that's one piece. Now, when you ask us how Keiser influences the EXOS brand and our approach, well, that one's really simple. We have a continuum of care that we like to offer across all these different disciplines, right? In most simple terms, the above the neck mindset, and we do all our great work with our nutrition team, our movement stuff, it also includes physical therapy and all the things that we need to do structurally that way into the highest levels of professional athlete and sport, and then we have to help people recover. So we need to beat them up less, and that will help them recover a little better as well. If you were to take a singular approach for this organization, which is serving 300,000 lives a day, a lot of those in population health, a lot of them at the most elite level, some of that active aging component of it. If you look at that and say, I need to engineer a tool that I could use across all of our populations, regardless of where they're at, that allows me to teach any movement at any load, at any speed, for all of our specialists, from physical therapy to everything that we do on the rehab front into high performance, whether you're teaching the speed aspects of it or trying to improve the force velocity continuum, right? Like that's what you want to have. And oh, by the way, we need to do it, this floor space is really valuable. We need to do it per square inch. And if I could do that, I need it to be super versatile to serve those populations per square inch. And that's essentially what Dennis engineered and designed for us. If we were going to do rack systems, we need the rack systems to do all these things for that population. The triple trainer was a complete game changer. When you look at the firepower of the functional trainer brought together in a 3-pack to do that on a floor that you can put anywhere. And from that, you can do almost everything in our methodology at any movement, at any load, at any speed. And those are the types of things that started to become super powerful for us. So how we show up at a professional sport, franchise and organization, or inside our walls at EXOS might look very similar to how we show up at a lot of our, 30% of our Fortune 100 clients. And that means that you and I can learn one system and one methodology that is the EXOS methodology powered by Keiser.
Yeah. So I hear not only has Keiser, and whether it's dynamic variable resistance or other equipment, not only has it allowed us to improve our clients and athletes' performance, but it's also changed the way we have designed gyms and really changed the game in that way. But one thing I'm curious about is, so how many patents do you
I don't know.
might think you have? No, who knows?
I don't know. There's a fair number.
A few. So when you are thinking about a new piece of equipment, what are your priorities as you're designing a new piece of equipment? What are your must-haves? What must it do first?
I don't compromise well.
No, he doesn't.
Okay. So it has to do everything that I can possibly do at that given time with the things that we have available, knowledge-wise, material-wise, everything. And design is always a compromise to a certain extent, but for me, I fight it to the end, and I seldom end up compromising. So I set my goals to replace the iron with something, and we looked at a lot of different things. We looked at electric motors, which people have electric motors on machines today. We looked at those back in the mid 70s. But the inertia of the motor and the power to get an eccentric contraction there are limits. There are limits to that. There are really not much in the way of limits to what we do. We make an 800-pound squat machine, a 1,200-pound, now it's a 1,600-pound leg press machine. I mean, shoot, I keep telling our people, I said, we're going to have a ton of resistance behind a leg press before too. I mean, this is crazy. And so then you start thinking, all right, now if I'm going to have this, what do I have to do to make it fast? And to make it fast, you have to keep that moving mass back to mass. Mass is the enemy of speed. Okay, a lot of people like to say, our machine's built like a tank. Ours cannot be built like a tank. Okay, ours has to be built like a fighter jet. It has to be agile. It has to be fast. It has to be able to turn quick. Okay, meaning we have to be able to go out and come back quick. We can't have, like Mark was saying earlier, it would float off you. If you kick the iron weight, it'd float right off your foot because that iron is still going and your foot's already coming back. And so you have to get rid of this mass so that resistance is against you all the time. And it's not just against you at some light resistance because you're happening to be backing away from it, but it's so light in its function that it's giving you that eccentric contraction of the same resistance you pushed it out. Meaning that same force curve you had going out, you're getting back. But the mass, accelerating that mass coming back, of all of the moving mechanism, we've eliminated the iron weight stack. But we still got mass in even the moving mechanism. And then we've got mass in the human's arms and legs that we have to deal with as well, okay? So we know that those things are going to be a factor. So we can't eliminate those, obviously, but we have to take them into consideration. So it is, it's not compromising any of that. You know going into it, I just redesigned our leg extension and leg curl to make them faster. Now people, Keiser said, well, yeah, we're always fast. Well, but our athletes, that's all relative term. Okay, you could say a rabbit's fast compared to the tortoise, okay? But, so it's all relative.
So what do you, let me ask you, what do you, when you say to make our leg press or leg extension, leg curl faster, what do you mean faster?
You cut back on whatever the weight of the material is that's actually moving during the exercise. So let's say it's a leg press machine, okay, and we've got the 1.5-inch square tubing, and we've got steel tubing, and we've got a steel plate, and we've got a rubber piece that the foot goes against, and all these kinds of things. Well, all of those things are part of the moving mass, and the linkage going back is part of the moving mass. So those all have to be lightened up. So now we have to go to aluminum, or we have to go to, I told Mark earlier that the day will come when our moving parts are more like a bicycle, like carbon fiber, and some of the lighter, stronger types of materials. And we'll go to aluminum sections that you would have on a bicycle probably fairly soon, because the athletes are getting so fast that we have to stay up with them.
Sounds like a race car. Like
It
you're
is
always trying to
exactly
make
a
it
race car.
lighter.
I'm smiling because these conversations, when you start to nerd out on this, like if we even think about the functional trainer, we were walking through the factory, which Dennis's brother has ran and helped develop that factory, and it's an amazing experience to walk through. But I remember asking him one time early on, I'm like, why are you using a rope versus cables? And he's like, well, and then we started to go through because one, obviously cables start to wear out. Plus they have a lot of mass, which ultimately leads to inertia too. Like it's just a bad solution. And he points at that test dummy over there. It's going back and forth and back and forth. And the rep reader says, that's it, 10,500,000, whatever, on the same piece of rope, because I'm not putting the force on the rope. There's nothing to wear out. But it goes now to today. If you ever look at the end of any one of the Keiser pulley systems, at the end of that will be this very beautiful precision race car-like part. And you're looking at it, it's like, boom, and I just need to clip my handle on it. It's because that also decreased the mass in that unit. Instead of a big old carabiner on it, or a carabiner to something else that adds mass to the end of the cable, it allows us to train faster. We just need something that we can clip on. It's the most elegant solution. Formula One dials in more how we think about Keiser. Massive horsepower. You can lay down the force, right, in those ways, but it needs to be quick and agile for us to do that, regardless of the population. We know that makes sense to a world-class athlete. High forces and high velocities and like very dynamic. But also, if you flip all the way out here, like as we start to mature and we start to age a little bit this way too, we do care about power. And healthy aging and this cognitive function and central nervous system component and our ability to generate power for daily activities and protect ourselves from stuff is the exact same thing that we're doing to those earlier bodies. The big thing is we can train the earlier bodies and these older bodies without inducing a lot of the trauma that normally comes with training. Regardless of how fast you go with your movement, it's still safe and it doesn't load the joints the right way, so we can walk away actually feeling better after a workout than during.
I notice I don't get as sore.
That's exactly right.
Not a bad thing.
Because you're not overloading the muscle at the wrong point in the range of motion. And you're not overloading the tendons and all the other things.
It's hard, though, to change people's mindset. Like, oh, I have to go back at 4 counts and up at 2 counts. And I might go to them and say, hey, again, they've progressed along, and I'd like you to get as many reps as you can get in 7 seconds. How many reps do you think you can in 7 seconds? First, it's very slow, and you're not going to hurt yourself. And then all of a sudden, you start to see the expression of that, and it's like, their nervous system's lit up a little bit. They're like, wow. But it's a whole new universe. You go drive a race car versus a tank, it's a big difference. The race car is way more fun. And the great thing, I was just laughing with Dennis about this, part of the challenge with Keiser is this stuff is built so well that you still see stuff that are 10, 20 years old. and it's still in place at a lot of our facilities and sport facilities from those generations. But I think that's where I'm also really proud that Keiser's changed that with the intelligence that we can actually gain out of how people are performing in that equipment.
Your equipment is so, well, I mean, I would say we pressure test equipment with bigger bodies and more pounding than almost anywhere in the world.
All day long.
You've still got Keiser racks, functional trainers that have been through millions of reps with some of the biggest bodies on the planet, and it holds up. But on your point of, like on Mark's point of, all right, we're talking about race cars, speed. Now I think that may have ushered in some of VBT or velocity-based training and how that is so such a focal point now.
Welcome to the conversation.
So, all right. So, what does the future look like in Keiser? And you've got a 400 line and new outputs and screens and data that are being driven. So, what does the future look like, or is the future here?
Future's not here yet. Future's always in the future.
Yes.
No, there's some things that we're working on that I really can't talk about. But it has to do with the engine, okay, that main part. And it's all about how well that engine's made. And the engine for us is the cylinder, and cylinder has cubic inches just like an engine has. We have 2 cylinders on a machine, that's 2-cylinder engine. It has a certain amount of cubic inches. This is what we do. Now it's designing the engine so that it is faster, okay? Along with all of the other things that have to get lighter, it has to get lighter. It has to be able to move quicker. Basically we're building high performance engines, and that's really what Mark's doing. Okay, he's building high performance engines here. When a human being is an engine, okay, and unfortunately, what the standard strength coaches have been doing, and I kind of use that as a derogatory statement because I would refer to them as performance coaches, because I feel that strength coach puts too much emphasis on strength, and performance is really what it's all about. And so, but the standard strength coaches are still trying to put big giant diesel truck engines in Formula One cars because it's all about strength. And anybody that's going to build an engine for any kind of a use or a vehicle has got to understand what the use of that vehicle is going to be. And so you don't want to put a big giant diesel truck engine in a Formula One car, nor would you put a Formula One engine in a truck. They have 2 different purposes. They both produce the same horsepower. I mean, you have cars going up and down the road here at 400 horsepower, and you got trucks going up and down the road at 400 horsepower, and they're both totally different engines. One has more of a focus on strength, the other one has more of a focus on speed. Okay, we have to look at that same thing when we're, as coaches, when we are designing an athlete, and we are building that athlete, we're building that engine. And I have to look at the same thing when I'm building the engine that has to power this athlete. In other words, has to resist this athlete. So it's all of that moving mass that we talked about. But that's kind of the future. And like Mark said earlier, I'm not married to pneumatics. It just is the best thing that we have seen so far. People used to tell me, well, why don't you make a pneumatic bike? Because it's no good for a bike. But magnetic is. So we came out, we introduced the magnetic resistance bikes.
Award-winning bike.
And so, because it serves that purpose very well. So I'm not caught up or prejudiced as to what I use. I only want to use the very best for that particular situation.
Absolutely.
Which one of your taglines is, because good enough
Isn't
right?
A man who doesn't like to compromise.
That's right.
Yes.
So, curious for both of you, what's your favorite movement or piece of equipment, Keiser-wise? Just personally, what's something you're like, love this?
I think I first have to start with the insights that the 400 is actually giving us back, because the precision that we're able to serve our clients now and the discussions that our performance team is having, I mean, it is amazing of how we now need to be able to use this versatile tool and tune it exactly to them at this point in stage and where they're at and where they want to go. Like, that has been really cool, really, really, really cool to see. And I think the future is always in the future, but the platform in the Keiser, the 400, has taken a bunch of really sharp people. Like, I'm so proud of our peers globally, all around it. EXOS coaches in the NFL, the NBA, the Premier League. There's so much good thought out there in how they're taking and training and serving that elite level client, but also what's happening inside the physical therapy clinics and inside our corporate sites. Like, the mindset of people today allows them to like really nerd out, to be able to get the insights to better fulfill their responsibility to the people that they serve, the clients that they serve. So like, and we are just getting started on that thanks to the insights that we're gaining. That's going to be game changing. After that, what do I love playing around on a Keiser? You name it. You give me a functional trainer, I like that type of stuff, but I also like high force stuff. So you give me a Keiser squat and a little bit of caffeine, and I'm going to be pretty happy. And also, like, in the same kind of frame, if you will, the Keiser poles, I think that gets super fun for me. And I do love, I'm always like, I have to have a Keiser half rack, because the Keiser half rack is my bench. I can load up all the mass stuff. I can do my straight bar stuff. The high pulleys, to me, where I can unload, but probably more importantly, do all the pulling and chopping and lifting, but freaking heavy. I love doing that stuff and trying to generate as much power as I can. Yeah. It just isn't what it used to be.
You're better than you once were.
Yes, I'm maybe as good as I once was.
Anything to add on A400 specifically, and things that what you're most excited about, or something that you and your team made sure were in the readouts and the outputs and the updates?
Is giving more information. Okay, we've talked about the strength side. Okay, and I think the big focus on strength came because it was easy to weigh some mass, or whether it's a rock or whether it's iron or whether it's a log. It was always easy to weigh that, and that was what you could lift. And so the big focus, for the simplicity of it, is what drove that idea of strength. It's pretty hard to see power because people don't relate it. They can see speed, and so they have that kind of an idea. But power is that combination of speed and strength. It's speed times the force. And so that's what we show on the 400. We show the velocity on the 400. We show all of these things left and right because they're independent. So we can see the speed differences. We can see the power differences from left side to right side. In an athlete, that's very important because they can't be too asymmetric. Good athletes are within about 5%. Okay, and you can't have an 8-cylinder engine that has low compression on one cylinder and all the rest are fine. They can all be one level. It doesn't mean high or low, but you can't have one different than the other. Okay, if that's one's different than the other, you're going to have a problem with that engine. And so it's the same thing here. We need to know how that athlete is functioning, because if they can generate more power with one leg than they can the other, and they're a sprinter, they're either going to run in an arc, which the lanes don't go that way, or they're going to force their body to run straight when it doesn't want to run straight, and they're going to have a problem. And we've seen that problem. So it's easy to look. In fact, I had coach tell me that one of his girls, 100-meter sprinter, pulled a hamstring. And he started to tell me which one. I said, don't tell me. Let me tell you. I pulled up her 420 test, and I said it was her left leg. He said, yeah. So it's because the right leg had more power. Left leg was stretching to try to keep up with it. And when you're stretching, almost like a baseball player running to first base, and a lot of times they'll pull a hamstring, run into first base because they're stretching to get that last step in. Same thing for her. So we start giving this kind of information, and those are tools that the coaches can use, physical therapists can use, in knowing whether this athlete is ready to play or not, or to return to play if they've had surgery or had an injury. So it's that kind of data, and then putting it into the form that is most meaningful to them is the hardest part. Easy to get the data. Now we got to put it in a form that's meaningful to the athlete while they're exercising, but also meaningful to the coach or to whoever's training that person, so that they understand it as well.
Agreed. This generation of performance coaches on that continuum of care is more educated and higher expectations about getting the information out and have an ability to prescribe precisely back against it. Keiser now gives them that live time, but we also need to understand it's, as Dennis just said, it is the ability of the client or the athlete to see it live time, right side versus left side, and have their aha moment, because that's what it's all about, is actually how they're interpreting that and performing. And you get to a peak power, and maybe they get their opposite side up to another level of that equal side of peak power, left side, right side. But then you watch this side on their dominant side stay up above 80% over 8 reps. Even though they just hit this peak power here, this one may go, right? Oh, I'm peak power, and then all of a sudden it's 80%, and all of a sudden I have an average power over 8 reps of like 52%. So now we have asymmetry and power asymmetries over that decay. So it's just insightful, and that gets people's wheels starting to spin, and they ask the right questions, and it gets us to ask the right questions. And I think just the more insights we have, the better we're able to do our job collectively and partnering side by side with all of our clients.
You can't improve what you can't measure. So we've got to measure it first. Then we figure out, now, what is it going to take to improve this?
Efficiently, so we don't put more load on the people.
That's right.
And when we put too much emphasis on the strength component, we start looking at this very slow speed of movement and the strength that we produce at slow speed. But like Mark was talking about with the athletes and an older adult, he wasn't calling himself an older adult. But I am. but those things that we do, we really need to be training our strength at the speed at which we perform. If it's an athlete, they got to train at the speed of the game. They got to develop their strength at the speed of the game. Okay, if we're an older adult, and you watch older adults and they shuffle and they move slow, and they lose half of their speed and half of their strength from age 30 to age 80, and they don't do anything about it, that's when their balance goes bad. Because if you stand on one foot and you watch how fast those muscles have to fire in that ankle to keep you balanced, that's part of the speed at which we're talking about. We've got to train the brain to continually control those muscles at optimum speed. Because the speed of life still requires an awful lot of speed. It's just not the speed of the game in competition, but it is the speed of balance is a big thing. If you get pushed off center, you've got to react quickly.
I think right now the heyday in, we often talk about lifespan, which we don't know that we can change. Health span, we definitely can have a positive impact, and Dennis has been passionate about that from the beginning. But I think what we're all passionate about at EXOS and at Keiser is play span. Like that's really what we want to do, what we're passionate about, as long as we can be able to do that and not put ourselves in harm's way. When you look at the current, right now, lean body mass, and keeping your lean body mass is very active conversation as the fountain of youth. It is what we need to hold on. And then the second thing that we'd love to talk about is this cognitive function, and we have dysfunction in Alzheimer's and dementia, different diseases of cognition. When you truly look at the fountain of youth, it's what Dennis just said. It's actually keeping your abilities and keeping this relative power and your central nervous system very sharp. That is the fountain of youth. And that, as much as we train anything, we train above the neck and we train this cognitive function for this neuromuscular system. We train the nervous system. And the longer you can hold on to that goodness, the younger and better performing, living with purpose and passion you're going to be. The reason we don't, because we also, as Dennis just said, we're saying as we age that you have to slow down, but you should resistance train. But like the whole thing just goes slow, and it's not. You can still be safe, and you can train at speed, and it will help your everyday quality of life. That's the fun part, and that's why I said these things on this continuum of care and the continuum of aging, from down here with this, you know, the outliers, and they're young and they're outliers this way, to outliers in this wonderful world of longevity and play span. If you start to look at them, they're pretty much stacked up the same way against their populations. And that's what's fun, and that's why we can actually identify it, get the information out, and then be precise about training it for them. Do it in a safe way, but also do it having a ton of fun, engaging.
Well, you two live it. I
We
see
try
you
to.
on your mountain bike. I've seen videos of you on your tractor, fixing cars, on your bike. So your representations.
We try
of
to
the
be.
brands.
We try to be, but that magnetic resistance on the spin bike or on the total body trainer is a bit of an ass kicker for me now, and then it's too true. Doesn't let off. My mountain bike, I can let myself off.
That's right.
It is true.
That's right. Before we wrap up, anything that you guys would like to cover or chat on in particular?
I think we hit a lot of it.
We did hit a lot of it.
Yeah.
It's just it's getting people to change their mindset. We're so used to doing something a certain way, and lifting iron or lifting against gravity has been the mindset for so long. And what we really need to do, just like you asked me, you know, what is it I look at when I design a new machine, or what's the future look like? The future for us as human beings has to be that we have to train ourselves for the future. We have to continually train ourselves so that we can get the most out of life. Okay, we may not add any real life to the years to the life, but if we can make it a better life, because we've taken care of ourselves, and we've taken care of ourselves safely. We haven't injured ourselves or come up with an excuse to tell the wife, well, my shoulder hurts today, I'm not going to go to the gym, which is always something we're looking for if we want to get out of a task. But if we can do it safely, and which is again why we do what we do, that to me is the most important. The equipment by itself, it doesn't do anything. Mm-hmm. It's only when it does some good for somebody else. Mm-hmm. That's when I feel good.
Mm-hmm. Keiser has been EXOS's competitive advantage, regardless of where we show up, in sport, in work, or in life. It's one of the most valuable tools to put in the hands of our amazing practitioners to allow them to best help our clients achieve their goals efficiently. And I mean, I think when you get into that, and we can do that in a way that's as thoughtful as what Keiser has done and as thoughtful as what EXOS has done, in building really special environments for special people, special places where they can go and practice this performance, living with purpose. I think that's this part that gets unbelievably inspiring to me. We've been doing it for a long time, and what energizes me most is I think both the consumer, whether that's our clients that are passionate now about lifespan, health span, play span, or whether it's our clients that actually make a living from their play span. I think those two things have been answered by the same question of how they have an individualized game plan and a great team supporting them to help them go achieve those goals. And Keiser by EXOS has been doing that for a long time.
That's right.
I think too, the partnership, the friendship, but in this case, probably more the partnership is really important because we just make the tool. He delivers the end product, and so the two of us collaborate so well together. Our favorite times together are when we are in this zone of just, well, what if we did this? What if we do that? What if we do that? And we're back and forth doing these things, but those are the great times, and that's really how things come. If we didn't have that, we'd be in our own vacuum,
yes,
doing our own little thing, but we wouldn't be learning from each other, and we have to learn from each other. And I think the other thing is that we built our products to take human performance to a much higher level.
yes.
But without EXOS and people like EXOS, it just becomes a statue. And I'm not in the mood to build statues. Okay? So we have to deliver that product. Mm-hmm. And so the two of us together, we build an exceptionally good product, and they deliver the goods, and they do such a great job of delivering those goods. You can see that from their combine stats and all of that. So it's two people. Maybe it's a little bit like Thomas Edison and Harvey Firestone, and who was the other guy that we used to go picnicking together? Oh, Henry Ford.
Yeah,
Henry Ford. I could see why those guys did what they did, because that's the same thing here. Is that we each work in different areas, but we work also in the same area.
Yeah.
And we are greater than the sum of the parts, and that's to me is a perfect relationship.
Absolutely. Greatness is a team sport,
Mm-hmm.
and this has been a purpose-driven partnership to fulfill our responsibility to the field and to this diverse population that we serve. And when we're on solving something, we do take that to heart and really try to meet that end thing, and we don't compromise very well between the two of us. And at the end, what you do is you come out with something that's been really well thought through, that is going to sustain the promise over the long term, and how we have a really thoughtful and reliable solution for all those people we serve. And I think that's what it just gets fun. More to come. We aren't slowing down. Well, we train fast. We may not move quite as fast as we used to.
Not done yet, though.
No.
Not done yet.
We just don't take too many wrong steps. We're more wise than we used to be. Joel, thank you very much.
Guys, it was a pleasure, my privilege. Dennis, thanks for wearing the Ilskin boots. Mark, look great as always.
Gray.
Appreciate it.
Laid back. Thanks, Joel. And thank you, Dennis.
Thank you.
Thank you.